Students, now we are going to discuss about adjoint of a matrix. Adjoint of a matrix. Here, let A is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. A be this matrix. Let A be a 3 by 3 matrix. Aij be the cofactor of A, denoted by Aij be the cofactor of Aij. Then adjoint of A denoted by adjoint A is defined by adjoint A is equals to transpose of A11, A12, A13. Similarly, A12 here transpose of A12, A13, A21, A21, A22, A23, and A31, A32, A33. This transpose of this is equals to A11, and then this 21, it goes here, A21, and then this goes on here, A31. So this row, this column goes into a row, and then second one similarly, A12, A22, A23, A32, and then third one similarly, A12, A13, A23, and A33 in this form. This is adjoint of A. Here, students, may you have confused. Let A is equal to this be 3 by 3 matrix. So Aij be cofactor of Aij. Then adjoint of A denoted by Adj. A is defined by adjoint of A is equal to transpose of this cofactor of A, and this is equal to interchanging the row and column. This is adjoint of A. In this way, we studied about the adjoint of matrix. Students, let's look one example of adjoint of matrix. Example, let A is equal to 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1, for example. A is equal to this one. Then we have A11 is equals to, this is cofactor of this, A11 is equal to 1, A12 is equal to this 2, A13 is equal to minus 3, minus 2, and then A12 A21 is equal to minus 1, A22 is equal to 3. Similarly, A23 is equal to 0. And then again, this one is A31 is equals to 0, A32 is equals to -2, and A33 is equals to 1. Then their cofactors we can write. So their cofactors are A11, cofactor of A11. This means cofactor of A11 is equals to cofactor of A11 means this is 1. So we'll omit this and this. So we can write 3 0 minus 2 1, 3 0 minus 2 1. This is equals to 3 times 1 is 3, minus and minus became plus, and then 2 times 0 is equals to 3. Similarly, cofactor of A12 is cofactor of A12 is equals to cofactor of A12 is this element. So this and this out. So minus 1 0, minus 1 0, and then 0 1. So we can write minus 1 plus 0 is equals to minus 1. Similarly, A13 is equal to cofactor of A13 is equals to, this is cofactor of A13 is -2 here. So this one is this and this out, minus 1 3, minus 1 3, and then 0 minus 2. This is equals to 2 times 1 is 2, minus 0 times 3 is 0. So 0. So 2 minus 0 is 2. Similarly, we can find A21 is equals to, like the same way, and A22 also we can find, A23 also. Similarly, A31, and then A32, A33 also we can find by the same way, in this way. Then after, suppose this one is 2 1 2 6 2 5, its correct value will come this one. Therefore, by definition, by adjoint of A is equal to transpose of A, transpose of A11, A12, A13, A21, A22, A23, A31, A32, A33. This is transpose of this one. Then after this is equals to, we can write this is equals to, here we are writing here, adjoint of A is transpose of this is, according to the definition, A11, A21, A31. So here is A12, A13, A22, A, here 13, A, this one A11, A12, A13, we wrote it here. Second one is A21, A22, A23. A23 is here. A31, A32, A13, A23, and then A33. This is 32, 32. Okay, this one. Now by putting the value here, this A11 is, we found 3. Then A21, A12 is, we have -1. A13 is, we have 2. A21 is 2. Similarly, A22 is 1. And then A23 is 2. A31 is 6. A31 is 6. A32 is 2. And then A33 is 5. and this is the required answer of adjoint of A. In this way, we solve these questions